I'm going to do problems 4 and 6 from the Quantitative Energy worksheet 4. But remember, I hope you're starting to notice that they're the same problem over and over again. You have to find yourself on the heating and cooling curve. Okay? And remember, we have temperature on the y-axis and time or energy on the x-axis. And if you're going to the right, you're adding energy to it, the system absorbing energy. And if you're going to the left, you're cooling or releasing energy from the system. And we have a solid section, so you can heat the solid. Right at point B, you start to change the phase from solid to liquid. At C, it's all become liquid, and you can heat through the liquid phase. At D, you start to boil and evaporate off the liquid until at F, you have completely changed it to a gas, or at E, and then up through F, you have the gas phase, where you can heat the gas. Or if you're going backwards, you're going to cool the gas, condense the liquid, condense it to a liquid, cool the liquid, freeze it to a solid, and then you can cool the solid, depending on whether you're adding energy or releasing energy. You find yourself on this curve, it's how you decide what equation to use, what form of the equation to use. Okay, this is 65,000 kilojoules of energy. So I know our Q is 65,000 joules. Is added to 150 grams, so that's our mass. So I know I'm going to be going to the right. I'm going to be heating, adding energy to this system. And it says ice at 0. Remember, for water, the melting freezing point is 0, and the boiling condensing point is 100. And this says ice at 0 degrees. All right, so ice, that means it's solid, and at 0, so it's not going to be over here at C, because that would be all liquid at 0. It's not going to be somewhere in the middle. It's going to be right there at B, because it says it's ice. That's solid. At 0 degrees is solid. Okay, you're going to add that to it. What is the final temperature of the water? Okay, so we're going to have to see where we end up here, but it looks like we're going to melt the solid completely to a liquid and then raise the temperature, and that is our question. Where does it end? At what temperature does it warm to? All right. We're at least in one section here, but probably in two. So we've got the heat of fusion here, and we've got the specific heat of the liquid. We're in those two sections. So what we're going to do is, we know we have 65,000 joules. We're going to see how much energy it takes to completely melt that ice to a liquid at 0 degrees. And that equation in that section is Q is equal to mass times the heat capacity, the heat of fusion. All right, well, let's see how much energy it takes. It's 150 grams, and if you'll look at all those constants given to you, the heat of fusion is 334 joules per gram. The grams will cancel. Let's see how much energy we use up here. Remember, what we're doing is seeing how much energy it takes to take it from a solid at 0, completely melt it. In this section, how much are we using? So I'll take the 150 times 334, and I get 50,100. Okay, so it took 50,100 joules of the 65,000 I added just to take it from solid to liquid at 0 degrees. So I'm going to take my 65,000 joules, and I'm going to subtract the 50,100 it took to melt it. 65 minus 50,100 leaves 14,900 joules left to heat the liquid. So we're going to figure out what temperature. So but again, we're just going to use the same equation, but for this middle liquid section. So Q is M, heat capacity of the liquid, delta T. And we have the Q that's left over, we have the mass, we have the heat capacity of the liquid. What we need to solve for is this change in temperature. Okay, so we're going to divide MCL out of both sides. So delta T, remember they're going to cancel there, is Q over mass heat capacity of the liquid. So the Q that I have left is 14,900 joules divided by the quantity, 150 grams, times the heat capacity of the liquid, which is 4.18 joules per gram degree Celsius. Grams cancel, joules cancel, and we'll be left with an answer in degrees Celsius. So we take our 14,900, we're going to divide it by the quantity, make sure you put this in parentheses so your calculator knows how to do it, times 4.18. So 23.8 degrees Celsius. That is the temperature change. Since it started at 0 and it changed by 23.8, that means your final answer is 23.8 degrees. So it took 50,100 to melt it, and the remaining 14,900 was enough to raise the temperature to 23.8 degrees. Okay. And then what we have left is the bar chart. I think you're okay with that. Remember, this is just ice. And we have an initial condition and a final. So initial and final. It started as ice, it ended as water, it's still water, doesn't make any difference. But it started as a solid, ended as a liquid. So 1 bar of phase, ending at 2 bars of phase. 1 for solid, 2 for liquid. It starts at 0, so I'll give it 1 bar of temperature. Ended at 23, that's nearly room temperature. I'll give it 2 bars. So it went from 2 to 4, had to gain 2 bars of energy into the system. Okay, and I hope you're starting to notice that it's the same problem. You find yourself on the curb, how many sections you're in, and then you solve the equation for each section. We solved it for the heat of fusion, we solved it for the liquid, using the energy given. All right. And I'll do 6 here real quick. I'll try to make this real quick. So an ice cube tray full of ice at -7. So that's, remember, for water, this is 0, and this is 100. So it's down here somewhere, okay, at -7 degrees Celsius. Is allowed to warm up to room temperature at 22. So that's up here somewhere. This is 0, this is 100. So the highlight is we're going to raise the temperature of the ice, then we're going to melt it to liquid, then we're going to raise the temperature to that point. So I'm sure you've noticed we are in 3 sections, and it says how much energy must be absorbed by the contents of the tray in order for this to happen. All right, 3 sections. We're going to solve for this solid section, for this heat of fusion section, and for this liquid section. So those are our 3 equations with our 3 constants. So we're going to solve the equation Q equal M heat capacity of the solid times the temperature change, and that'd be 7 degrees in there. Then we're going to solve Q is M heat of fusion for this section here. And then we're going to solve Q is M heat capacity of liquid, delta T in this section, and in this case, the delta T is it goes from 0 to 22, so that'd be a 22-degree change. Okay, so let's just go ahead and plug these numbers in. So mass, it says it's 235 grams. The specific heat of the solid, if you look up on the top of the page, is 2.1 joules per gram degrees Celsius. Change in temperature, it started at -7, ended at 0. That is a 7 degrees Celsius change. Get out your calculator. 235 times 2.1 times 7. So 3,455. 3,455 grams cancel, Celsius cancels, joules. So it takes 3,455 joules of energy to raise it from -7 to 0, to just warm the ice, to make those little particles vibrate faster. Second one, it's still the 235 grams times the heat of fusion, and if you look at the constants at the top, it's 334 joules per gram. Grams will cancel, so 235 times 334 is 78,490 joules. So it took 3,455 joules to warm the ice. It took 78,490 to completely melt it to a liquid. Now we'll figure out how much it takes to raise the liquid from 0 to 22 degrees. So it's 235 grams. Specific heat capacity of liquid is 4.18 joules per gram degrees Celsius times the temperature change from 0 to 22 in that section is 22 degrees Celsius. Grams will cancel, Celsius will cancel. We will be left with an answer in joules. So 235 grams times 4.18 joules per gram degrees Celsius times 22 is 21,611. 21,611 joules. And in order to find the total, all we got to do is add them all up. So 3,455 plus 78,490 plus 21,611 is a total of 103,556 joules, or we can convert it by moving that decimal over, convert it to 103.6 kilojoules of energy needed to take 235 grams of ice at -7 to heat that solid up, to melt it completely to liquid, and then to heat it up to 22. All right, make sure you check the key as you do the other problems, and give it a try.